Welcome to chapter 7. Chapter 7 is cell structure and function. We know that living things are all made of cells. That's one of our big 8 criteria, right? This is the chapter where we dive into what cell parts are in there, what they do, how they work together, and then finally how things move in and out of cells. And I'm just going to give you kind of a heads up that this is maybe what I would call the first hard chapter. The first chapter where there's a lot of new vocabulary that you really haven't seen before. It's the chapter where, if students aren't keeping up, they kind of tend to bomb the test. So just take that as me trying to help and saying, keep up and catch up and turn your stuff in and make sure you're engaged this chapter and you'll be fine. And if you're not, you won't. Okay? The chapter starts always with my least favorite stuff, which is what I like to call the old dead guy section, where you have to learn about the scientists that sort of paved the way in cell biology. We're going to make that as painless as possible with some pictures and some. I actually know a fair amount about these people, and they were all deeply weird people. So I'll give you some of the weirdness. You don't have to write it down. Just write down what's in bold print. Okay? You'll see what I mean when you get there. So we'll call them the pioneers of cell biology. Starting with this guy, Anton van Leeuwenhoek. He was Dutch. You can tell by the van. In the 16 and 1700s is when he's working. He is a big glass lens enthusiast. Is generally credited with building the first microscope, though he had lots of help from his lens grinder friends. And at first he did the stuff you'd expect with his new microscope. He looked at like his skin and his hair. And then he started to get weird. He has very, very detailed notes that have been preserved about looking at his own poop under the microscope and noticing there was stuff crawling around in it, especially after he ate meat. Because, of course, refrigeration wasn't what it is now, and everybody basically had parasites. And a lot of those parasites came from, improperly stored meat or past its prime meat. So that's Anton van Leeuwenhoek. By the way, all these guys were members of the first Western scientific community, which was called the Royal Society of London. The Royal Society of London was a group of scientists, all Europeans, all Western Europeans, that would meet in London, a couple times a year, and just basically share whatever they were working on. He was in this, so was this guy, appropriately timed for Halloween here. Robert Hooke was another microscope guy, early microscopist, and he got the hang of slicing things very thin so that you could sort of see through them under the microscope. He's famous mostly, he did lots of amazing work, but the thing he's most famous for is slicing a piece of cork real thin, which, the cork is like the bark of a tree, right? So he slices it thin enough that what he sees are all these regularly shaped square spaces, which we know are, the cell walls, empty cell walls of dead plant cells, right? Well, what they look like to him are the rooms in the monastery near where he lives. You know what a monastery is? Monks live there. Do you know what they call the rooms that monks live in a monastery? Cells. They call them cells. So this is the dude that, after slicing that piece of cork, he sees those spaces and he says, we're going to call them cells. Again, all you got to put in is the bold print. He's also what you would call a hypochondriac. You know what that means?
He doesn't like germs?
No, that's a germaphobe. Hypochondriac, you're close. It's that they think they're sick all the time. Whether they are or not, they always think they have something. And sometimes their big fat brains can even make them physically ill when there's nothing truly wrong with them. He's one of those, and his self-medication of choice is mercury.
Oh, no.
Which wasn't, that was fairly common back then. They called it laudanum. And the toxic effects of mercury weren't really known. What people knew was that it packed a heck of a kind of a euphoric feeling, like a buzz, and so people just assumed that was good for them. It was even prescribed medically, but this dude went overboard. He's like drinking a full glass a day. I think that's probably why. The beauty that you see there can't be good for your face. Yeah, so, okay, there's two. Here's a guy, Rudolf Virchow. He's generally known as a physiologist, but he contributed one major thing to our knowledge of cells. People used to think, oh, you can't see that, can you? People used to think some crazy stuff about where living things came from. Like, not humans, but I guess thinking we came from storks is pretty crazy. But let's see. It was called spontaneous generation, and people actually thought things like that maggots came directly from rotting meat. I think you read about one of the experiments that disproved that, Francesco Redi, right? They thought that barn mice came directly from old straw or old hay. So that idea that living things could come from non-living things was one of the things that this guy ended up, once he finds out about cells, he goes, well, this makes sense. Cells have to be coming from other cells, right? That has to be how it works. So that was his big contribution. As a physiologist, he made lots of discoveries. How he did it is a little bit of a bloody history. He invented what's called vivisection, which is cutting animals open while they're still alive to see their parts working. There are stories of him coming to Royal Society meetings with a stray dog he'd picked up on the streets and vivisecting that dog in front of the crowd, with the front row getting doused in, arterial spray. Pretty gross. And finally, we have a pair of old dead guys. Hung out together a fair amount. One was a plant guy, one was an animal guy. This is, I get the first names mixed up. One of them is Matthias and one of them is Theodore. Schleiden and Schwann are their names. Schleiden's the plant guy, Schwann is the animal guy. Basically, they both cut up enough samples and look at them under the microscope enough to conclude, okay, all plants and animals must be made of cells. All living things are probably made of cells. And putting their heads together and kind of reviewing what all the other people before them had done, they decide it is high time they put together a little kind of group knowledge that ends up being called the cell theory. Okay, so these two are the ones who put all of the other people's research together into what we've now called the cell theory. It's going to sound a little basic, but keep in mind that they had essentially just discovered that cells even existed. Cell theory has three parts. That is all. Number one, guess. Guess what number one is?
Everything has cells.
Everything?
Living things.
Every living thing? Yeah, that's the one. Number two, so we sort of started out thinking that cells were just these dead building blocks of living things. It's just that's the stuff, but the stuff that does stuff in there isn't cells. Well, what they find out is no, everything, all the parts, not just your structure, but function. Like cells have jobs, like they group together to make tissues and organs. So cells are the basic unit, not just of structure, but also of function. They carry oxygen, they filter blood, they conduct nerve impulses. All that is being done by cells. And then we conclude with Virchow's piece, which is cells can only come from other cells. And that is the cell theory. Questions? Pretty basic stuff.
So you said Sweden and I don't know how to say the last name. You said they like put other people's research together to create their own. Was it like they stole it, or
No.
was it just
No, this is like part of being part of this Royal Society of London was they were actually a scientific community. And like today's scientific community, you're always building off of the work before you, right? Like that's why, you know, scientific papers have lists of works cited, lists of references that are a mile long, because you're basically saying, okay, here's all the stuff these guys did before me. I'm continuing that work. So this is the early stages of kind of how science works. Yeah, good question. All right, from here, we dive into cell parts. So we're just going to start the first cell part that we look at on the very outside of living cells. Well, on the very outside of animal cells. There's something even further outside on plant and fungus and bacterial cells. But what do animal cells have on the very outside of them? Who knows? They have a cell membrane. So that is where we'll start. Cell membrane. We won't go far. I just want you to see this one part of the cell membrane. And then you can draw. So the cell membrane, our understanding of it, when we finally kind of got what it's made of and how it works, we often call our understanding of something a model. And so what we call our current understanding of the cell membrane is the fluid mosaic model. Look at the board. You see all that swirling around in that bubble? Remember the first time you realized that as a kid, like, oh, that's not a solid thing. That's like, that's liquid. There's rainbow colors in there. It's all moving all the time. That is a lot like what your cell membrane is. In fact, the molecules that make up a bubble like this are chemically very close to the molecules that make your cell membrane the way it is. So that's the fluid part of the fluid mosaic model. Your cells are not solid. Their membranes are constantly flowing like that soap bubble. And it's hard to believe because, right? Yeah, they're not, those aren't fluid. Well, that's because those are all dead, right? That's your suit of armor. That's your layer of dead cells protecting your live cells from having to be in contact with the big bad outside world. So it's a fluid shifting bilayer made of a whole bunch of stuff. That's the mosaic part. There's a bunch of other stuff besides the molecule I'm about to tell you about. But the one I just want to start talking about today is phospholipids. They're the molecules that are kind of like soap molecules. They're the molecules that make the cell membrane kind of behave the way it does. Because a phospholipid looks like this. Kind of like a balloon with two strings. And the two parts of this molecule make it special. The head is a molecule called a phosphate, which is just a phosphorus atom and 4 oxygen atoms. What it's made of isn't as important as how it behaves, which is that it has a positive end and a negative end, which is what we call polarity. It is a polar molecule. And polar molecules on Earth are important because they attract other polar molecules. And there is this one polar molecule that happens to be like maybe the most important one to living things on Earth. It's what we look for when we look for life on other planets. What polar molecule makes up an awful lot of a living thing, Tristan? It's part oxygen. It's polar because of oxygen. It is water. And so it turns out that the phosphate end of this molecule attracts water. We use the word hydrophilic, which means water loving. They're not in love with water. They're this molecule. Get the idea. That's not weird. Lots of molecules are polar and hydrophilic. What's weird is that the polar phosphate is attached to 2 fatty acid tails. And those fatty acid tails are completely nonpolar, which means they repel water, which we call hydrophobic. And that's weird, to have one molecule both attracting and repelling water at the same time. And what happens is when you shake a bunch of those things up in water, they start to arrange themselves in a very specific way. They put their tails together because their tails don't like water, right? So they shove their tails together and their heads are on the outside touching the water, and the tails are on the inside not touching the water. And you get this situation where all the, it's like a sheet. It's like a 3-dimensional sheet of these phospholipids, and then this part still touching water that doesn't want to, just kind of comes together, and you get this circle or this sphere of these molecules. And that's what makes up your cell membrane. All the other stuff floating in it is kind of secondary to that's the structure. Okay? And we'll end there. I won't make you draw this yet. Okay? If you didn't get a chance, finish that up. And I'm going to pass out some paper for you. And I'll tell you what to do with it in a minute. Everybody gets 2 sheets of computer paper. First thing I want you to do is take your 2 pieces of paper and I want you to tape them together using the tape that you bring to class every day. Like this. Tape them together with long sides together. Lay them down, kind of butt them up against each other, and just lay a strip of tape down on them. Need tape?
Yeah, I'm sitting at home on my back.
All right. And so, like I said, you get to draw today. You're going to begin drawing your dream house. Everybody knows what kind of house they want to live in, right? It's going to be decked out. It's going to have everything you want it to have. But I do insist that you include 7 specific parts. And you can make them your own, okay? You can make them different than maybe I'm envisioning them. But you have to have some way of getting yourself around in this house besides walking. You're going to be rich, right? If you're too rich to walk around by yourself, that's far too much work. You need a system. You need something to move you around inside this house so you don't have to walk. I said hallways with moving sidewalks. You can be creative with it if you want. You need a way to generate power. Okay, you don't want to be dependent upon the man for power, right? You're rich. You need a mailbox or some way of sending things out of your house. You need yourself. You need some way of keeping the riffraff out, right? You need a fence, an alarm system, gates, stuff like that. That'll all kind of be labeled together. You need a way of getting rid of trash, and you need a way of storing all your stuff. Those things need to be labeled. Beyond that, the house is yours. Take it where you want to take it, but label each of these parts clearly, and you're not allowed to color it. No coloring allowed. I know, I'm a monster. Okay, any questions? Okay, have fun.
Well, it was kind of more like so with the hallway with moving sidewalks, we have to have something moving in the house.
You have to have some way of transporting yourself and your guests around the house without you having to expend much effort.
Does that have to be like a part of the house, or it can be something in the house to like move?
Yes.
Yeah.
Can it be like an elevator instead? That's a way of transporting something.